Hey there, YouTube. This is SGM4306, and it's pretty early in the morning. It's like 6 a.m. Can't sleep, and so I thought I would modify my PSP. So I kind of want to get back into playing some of these games. I have a 64 gigabyte SDXC. I formatted it to FAT32. So here you can see if I go into information, yeah, 58 gigabytes, 28 is free right now. And this is running custom firmware, so I have pretty much all the games that I showed in my past video ripped onto uh, essentially the memory card. So this is all solid state. So I no longer have a need for this UMD drive, unfortunately. But I've noticed that the battery, so I bought a replacement battery for this. So let's just turn it off. Off. Okay. So I bought a replacement battery for this, and I just have it kind of hastily taped together. And this is written as 2400 milliamp hours, but when I open this up, it's pathetically small, the cell. So I thought, why not? So I'm going to gut this battery, use the circuit board in here that has the necessary circuitry. And I've noticed that this 2500 mAh battery that I pulled from a battery pack, like a USB battery pack, just almost perfectly fits in the UMD drive area. So I have no need for the UMD drive anymore since I ripped all my discs and I play them digitally. So I thought, why not remove the UMD mechanism and stick this battery in here and use this original circuit board so I can actually get a 2500 milliamp hour battery capacity, which is more than double the original battery size on this. So this will give absolutely awesome, double the runtime originally. So I'm expecting at least 8 to 10 hours off of this cell then. So we're going to do that modification now. So I'm not going to bore you. I've already done a teardown of this. I already have a video up. So I'm just going to quickly open this guy up, and then I'll show you me removing the UMD mechanism, and then we'll go ahead and wire this battery up. And so that'll be this video. It'll be, I don't expect this to take that long, maybe half an hour. But yeah, let me get to the point where I'm removing this UMD now. Okay, so I got all the screws out. Just before I go any further though and remove the front, exposing the LCD, we want to remove this UMD retaining bracket here. And so what you can basically do is, I believe you can, yep, so there are little plastic bits in here. If you very carefully flex the metal, you can remove it from this side first, I believe. So let's carefully do that. Let's see how, okay, yeah. So here, let me grab a pair of tweezers. Okay, we want to be careful because this metal is, well, bendable. So they're actually little rubber blocks. So you can see one here and they basically press against the metal to prevent it from coming off from these plastic pegs. So we want to get in between just enough so that we can release these. So I got one off there. Sorry if you can't see this in shot very well. It's not an easy thing to do. Okay, there. So I've removed more or less both of them. This one is still sticking a little bit. Okay, now we can see now this bracket's removed. And the metal, yeah, I did not manage to bend it. That's great. So we can slide it back and kind of twist it off. And the only thing that's holding it is a slotted rail on the side of the UMD door. And if we push it all the way back, there's a like a circular portion here. That's where you need to slide it all the way back so that you can just pull it out. And so now this bracket is removed, and I'll be saving this for future repairs. And so that's that. So let me pull off everything and get to the UMD mechanism inside. Okay, so the way I modded this board had some backlight problems, and it was the connector that had broken. So I ended up soldering very thin wires permanently to the backlight, so I can't really remove this this entire LCD module, so we're just going to leave it as is. So the wires that we are interested in though is this brown flat flex cable here. You want to lift that. That goes to power the motors in the drive. And the data cable is this guy right here. So we just want to get in there very carefully and release that flap. And then we can just take tweezers and pull out the data cable. Now, interesting thing to note is this is an optical drive, obviously, so there's a laser. There's pretty much on every single ribbon cable for every single laser, there's always this little 2 solder points. That's actually to bridge the laser diode, because the laser diode is static sensitive. So if you really are doing this in a professional setting, you would blob some solder on there before disconnecting the drive. You would not do what I just did, because you could permanently damage the laser diode. I've never had a problem with that. I've never damaged a laser diode by not doing that. But, you know, if you want to be careful, that's the way you really should go about it. Anyway, so what we are going to want to do, though, is carefully lift these. And we're going to probably have to remove the door to get access to the screws. This is going to get very hairy very quickly. Let's just remove this for the sake of not having it flapping. Yeah. I don't think there's an easy way around this. So, probably the easiest way now would be to remove this board to get access to everything underneath, because I believe there's maybe some catches or some screws, but let me fiddle around with this for a second. Oh my goodness, that was like the most annoying thing ever to do. So there are these little plastic indentations on either side of the UMD door, and there are these little plastic pegs that are, you know, permanently in there. So what I ended up doing was removing the entire circuit board so I can fiddle without having to worry about delicate connections. And so once I got that out, additionally I removed the spring. Basically this is just held in to, you know, part of the plastic door, like so. There we go, like so, and then it fits into the plastic piece here, and then there's a retaining clip. So all you have to do is get your tweezers in, and there are 2 plastic tabs on either side of this clip. You can work it out with some tweezers, and then just slide out this this metal spring, and that'll allow this door to freely flop then. Now after you do that, then the easiest way I found, don't get this stuck back in, is to get your finger. You can flex this door slightly. You do not want to put a lot of pressure on it though, and you want to use some tweezers to kind of pry from this side, and that'll allow you to free one of the sides of this hinge, and then you can just kind of slide it out slightly and wiggle it free to get the other side free. And this is absolutely necessary to get the UMD drive out, because there's a screw. You can maybe get access to this screw with the door still in place open, but you cannot access this final screw here, unfortunately. So anyway, now that that's all done, and I've already disassembled like this entire PSP, I have to put it back together afterwards, which is going to be a pain. There's just 4 screws to remove. Oh my goodness, that was like literally the most nerve-wracking, because when you have to start kind of bending plastic, you can easily crack it, in which case this mod would not be reversible. I'd have to buy a new UMD door if I broke the plastic. Or even worse, if I broke one of these tabs, then I would need to buy a whole new case. But anyway, once you remove these 4 screws, those are the only things holding the UMD drive in, and you can just kind of lift it out, and there's some compliant rubber discs that will kind of dampen the shock. And I'm going to keep this module because, well, I have other PSPs that maybe I need to replace the laser in the future. But yeah, you can see just how absolutely tiny this laser module is here. Let me get something to poke it with. You can see here these connections go to the they're not stepper motors, but they're brushless motors. You can see the 4 wires here. It's a bipolar motor, and then another 4 here, and there's some test pads for this one here. So this motor actually rotates this cog, which rotates this one, which rotates this worm gear shaft, and that'll move the laser head back and forth. And this motor here, obviously, is the spindle motor, and this is slightly magnetic in the center here because the UMD discs have a metal center part to the disc that this kind of locks onto when you insert the disc, so that it can grab onto the disc, and as it rotates, the disc rotates as well. You can see the laser here, the lens and the focusing mechanism, and it's very interesting. This is really thin, to the point where they didn't even include a backing on the laser. You can see the entire mechanism, which is pretty wild. There's a small potentiometer here for adjusting the laser output power, and you can see various lenses. Here's the optical pickup. So the laser is, let's see, I can definitely see this is the optical pickup. So basically the light is ejected from the laser, bounces off the disc, goes back through. There's a 45-degree angle mirror. It appears to be, it transmits in both directions essentially. So it reflects it into the receiver here. This picks up the data and then reads it. I would expect the laser to be, maybe this is a combined module. I'm not seeing a separate diode, so I'm guessing this is both the laser source as well as the receiver in there, because this is very simple. There's nothing on here, definitely just the lens tracking coils, basically, so that the lens can move up and down to focus on the different parts of the disc. Yeah, that's literally all it is. There's really nothing in this module. But anyway, now that we got that out, I'm going to set that aside safely to the side. And before I mount the door back in, I'm going to actually solder this battery up and get everything wired in, and then we can put the door back in. So let's get cracking on that. Okay, so we're pretty much all ready, just heating up the soldering iron, and we are going to want to, well, I had originally cracked this battery open. You basically just get a pocket knife and very carefully start prying. I pried, I think, around this side here, and you just want to make sure you don't puncture the battery inside. But if you just take like a scalpel or an X-Acto knife, you can very carefully get into that. And obviously I put tape to seal it back in because this is it's sealed from the factory, so obviously there's no screws or anything. And there we go. Yeah, I don't know if I've ever shown this in a video, but these cheap batteries, this is all that's inside them pretty much. This tiny cell, which is definitely not 2400 milliamp hours, and I can affirm I've used this battery and it's pretty bad. It barely lasts any time at all. But they're dirt cheap, so this is ideal for modding. So you can just buy a cheap battery just for the circuit board essentially. So we want to peel that off. So you want to be careful. This is a live circuit, so there. Don't want to short anything out. Just do one wire at a time. And after we're done, just tilt that out of the way so it can't short. And there we go. So this battery, let's pull this out. This is the circuit board itself. Okay, yeah, so this has a tiny little microprocessor, some kind of microcontroller, and some other support circuitry. So what this does is it actually sends a serial code to the PSP, I guess identifying kind of what the capacity is and what the status of the battery is. And the battery contacts just connect at the bottom here. So if you were to just wire positive and negative directly from the battery to the PSP, it actually wouldn't work without that data signal, unfortunately. So we need this chip. But we do not need this crappy battery now. So we are going to carefully try to extricate this guy. Okay, yeah. So it's just fit in there, and there's some masking tape on the top. And no surprise, an unmarked cell. So I'm probably, maybe might use this in the future, but this cell's kind of crap anyway. So then all we need, we can insert this very carefully, try not to bend any of the pins. Carefully back in there. And we are going to need 2 wires. To go from here, we'll cut a small hole in the side, and we'll have it external, and we'll wire this pack up with a little bit of length of wire. So let's see what wires I have. Okay, yeah, this IDE wire should be plenty enough. And we're not going to need that long of a wire. I'll cut it a little longer than I expect. You can always shorten a wire. It's harder to make a wire longer. Takes more work, but it's easy to shorten a wire. So this is IDE wire. This battery isn't going to charge at that high of a rate. This thickness of wire should be sufficient for that. So let's just remove, oops, sorry, this, twist the wires, and we'll go and tin it. That should be good enough. Do the other side. I should have legitimate wire strippers, but if you're careful, pocket knife or scissors ought to do it. And there we go. Wires are tinned, ready to go. Now we want to see, so positive is here, negative is here. Let's just reflow. Okay, solder's nice and shiny. So what we are going to do, because if we hook up the battery backwards, we'll probably destroy the circuit, and that will be no bueno. So I'm just going to take one of these, because this is unmarked wire, and draw a black stripe with some permanent marker, so I know what is negative, and the other will obviously be positive. So the way I wired this, positive is on the right, negative is on the left. Just going to take this wire, hold it here, and while I hold it, because I don't have a vise or circuit board holder, just going to kind of heat it up as I push the wire into place. This is really hard doing with one hand. That cool. And there we go. So now we need a small space for the wires to exit. I might just take a drill bit and drill a tiny little hole in there. Okay, just taking a pocket knife, you can create a little notch in the plastic, just enough for this wire to poke through. And so there's a little area right here where there's enough room for the wire to pass. Gonna have to tape this together, or a little super glue will work, but I'll just tape it because I want this to be openable in case I need to modify. Anyway, you can see that this wire will just fit with the UMD door closed, and I don't have to cut any of the plastic of the case. So this wire is gonna go here, is gonna go around right in the middle of the side, and the battery will fit like that. So we can fold these wires over and solder and put some tape to insulate. So what we are going to do now is, so we know negative is this guy. Now we want to, it's marked here on the battery, positive should be this, negative should be that, but never trust, assuming things. So let's just always measure first. This battery does have a little bit of charge on it, so it should be fine. So, okay, positive on the right, negative on the left, and it would help if you could see the meter. 3.5 volts. This is about maybe 50% charged, something like that. Not fully charged, obviously. So, okay, positive is indeed on the right. And just to doubly be sure, yes it is. This is one of those things, if you do wire this up backwards, this chip will likely go bang. So, not good at all. So, the way this goes, positive is on the right, or negative is on the right, sorry. I'm dyslexic all of a sudden. And our black wire is this one. So we have to solder things like this. So there's a little bit of solder I left on here. So we should be able to just heat it up and slide the wire in if it wants to work with me. Yeah, and these pads, you don't want to heat them up long. You want to be quick about it. Just double check. Okay, looks good to me. Let's wire. Go. Nothing feels hot. Turn off my iron. I should be done with that. And you can place this back on. So I'm just going to take some electrical tape. I'm going to use some masking tape here because it's pretty thin. And we're going to tape up the battery to make sure it doesn't come off, and tape up these contacts to make sure they're not exposed anymore. Actually, I might just use, I left some of the Captain tape here from when I disassembled. I removed, there's some protection circuitry that the original battery used. So yeah, let's do that. Okay, so just a little bit of tape on the sides. Don't want the battery coming open while we actually insert it. And that'll be good enough. Now, okay, add the tape off. We are just going to fold the battery contacts over just to insulate them. And I'll probably put a little bit more tape on there as well. Last thing we want is anything shorting. Since this is a pretty high capacity battery, if it wanted to, it could definitely melt your PSP. So there, that'll probably be good enough. So basically the battery will go in like such. And there we go. It'll fit in and the wire will tuck away like that. And that fits almost perfectly. Hopefully, you can slightly bend this bit if you need a little bit more room, because I think the UMD door might interfere with this edge here. But yeah, that fits pretty much like a glove, and you can see that fits almost perfectly. I couldn't have gotten luckier with the size of this battery. So yeah, let's reassemble everything, and I'm not going to bore you guys with reassembling all the circuit board into this. I'll reassemble everything and I'll get back to you guys and show you it working and charging. Okay, the final part of the modification is actually inserting the battery. So we are going to see if this will all fit. Looks like we're just gonna need to bend this little bit on the front and the side here, just to gain enough clearance. Yeah, it looks like with this battery, it is gonna be a bit of a tight fit. Okay, so the cell I use is just barely small enough. It's a pretty tight fit. I had to finagle it around. I had to kind of tuck the wire into the side here, and it goes just barely in, and I was able to just close this door, and there's a little bit of a gap here, but it just about shuts, and if I open this, the whole thing will fall out, so I'll pretty much just keep the UMD door shut all the time. But you can see here that it's charging. We can just put this door back on now. And yeah, it definitely would not fit with the original bracket. There's just barely any room left inside there. But you can see that she turns on. If we go into system settings, this battery was at like 3.4 something volts. You can see now it's about 20% charged. So I'm going to let this sit. I'm going to keep an eye on it. and occasionally, make sure it's not getting too hot. Okay, so this has been charging for, it's about 10 in the morning now. I think I finished this mod around 7-ish, so probably about 3 hours now. So we can turn her on, and yeah, about 100%. So we can unplug this, and it states that there's about 7 hours left. I'm not really too sure how exactly the PSP knows the capacity of the battery, because even though the stock battery is about 1200 milliamp hours, this replacement one that I bought off eBay is a no-name cheapo one that is supposedly 2400 milliamp hours. So I don't know if they programmed the chip inside the battery to report to the PSP that it has that much battery life. So all in all, I don't think this meter is going to be very accurate. This one should be, because this is based off of voltage, but this hour's remaining time is probably calculated from the reported battery capacity from the battery itself, which I don't really trust. So either way, I would go by this. I do have on my PSP Go installed a meter that always sits on the bottom of here. It's a modification to the CFW that will actually tell you the exact voltage and the estimated time remaining as well. So I usually use that instead of this battery meter, but it's a good idea just to keep your eye on that while you're playing. But yeah, you can see everything works. So yeah, I can play with this a little bit. I'm gonna run it for about an hour, see how the battery changes a percentage. But yeah, I'm just gonna fire up a quick game. Let's see, I've been playing. I started a new game of E7, so we can fire that up. And I'll give this a play for about an hour, and that should tell me kind of by what percentage is left, how long this should roughly last. So let me fire up a game of that right now. And you can see having this card, it loads up real fast. This is awesome. Anyway, yeah, everything works. So let me give this a play. Okay, so I've been playing for maybe 2 hours. We go over to battery. You can see I have about 80% left, so that would suggest, maybe 8 hours or so battery life. I'm not too sure about the accuracy of this built-in meter. Additionally, this battery was kind of sitting around for a month or two, just kind of discharged. So probably not the best condition. So I'm going to have to cycle this battery and kind of recondition it. Additionally, yeah, so far a lot better than the replacement battery that I bought. That I could maybe use for about an hour. Who knows how long that was sitting on a shelf, within a warehouse. So anyway, all in all, this is a pretty good mod. This will make it. They released like an extended battery pack for these PSPs that had a door that actually stuck out on these slim models because it wouldn't fit. So this is kind of equivalent to that, but keeping the slim form factor. So all in all, this is actually a pretty useful mod. If you have a PSP that you don't really care to use the UMD anymore and you just want better battery life, this is a great mod. The only caveat that I found, because it has a battery in there, it's actually pushing on the disk detection switch. So once in a while when you turn it on, it'll actually give you an error saying that the disk cannot be read, obviously because we removed the disk drive. So it'll detect kind of that, there's a disk read error. You can just exit out, hit O and ignore that. And I've only seen that once, and that was when I first turned on the system. So that's not that big of a deal. Yeah, other than that, everything works, and this is an awesome modification so far. I'll let you guys know about if the battery life improves, and I might eventually just kind of leave it on doing something, playing a movie or whatever, and see what the battery life is. Anyway, hopefully you guys liked the video. Like, comment, subscribe, whatever, and I will see you later. Bye.